Celebrating important events and holidays will never be complete without having a fireworks display. With a magnificent burst of colors in the night sky and loud explosive noise, fireworks make us feel happy, enjoy, and cherish each celebration. But behind these lights comes the dark side of it. In this video, let us zoom in on how fireworks impact our health and environment. Its development dates back to the 2nd century BC. Bamboo stalks are considered the earliest natural firecrackers used to ward off evil spirits in ancient Yuan China. By 600 to 900 AD, it was thought the Chinese alchemists created the first man-made fireworks using the first gunpowder. This black flaky powder can be produced by mixing potassium nitrate, sulfur, and charcoal. In the 13th century, fireworks began to be recognized and manufactured in Europe by Italians. They were used to celebrate religious festivals, entertain, and enchant the public. If you were a resident of Los Baños, Laguna, you know that the fireworks display is one of the highlights when hosting significant events such as the UPLB commencement exercises and the Banyamos Festival, which also marks the end of each celebration. Now, let us take a look at the chemistry of fireworks. Every action in a fireworks display lies behind its chemistry, which is based on combustion. The display of visually appealing colors is all produced with a specific mixture of chemicals burning through the air packed in a cardboard casing called aerial shell. What are fireworks made of? The composition inside the firework contains four vital ingredients: oxidizing agent or oxidizers, fuel or reducing agent, coloring agents, and binders. The typical fuel in the pyrotechnic industry known as gunpowder is charcoal. Other fuels can be sulfur, aluminum powder, and magnesium powder. Fuel combines with the oxygen released by the oxidizer to produce heat. It helps the firework propel into the air and blow up when the fire is added. Oxidizing agent produces the oxygen needed for the mixture inside to burn. Common oxidizers are nitrates, perchlorates, and chlorates. Metal salts are used as coloring agents to give fireworks their wide range of colors. Applying heat to the following metal salts produces a specific color. Other colors are commonly produced from mixtures of compounds. Lastly, binders are used to hold the mixture of the firework together in a paste-like mixture. The most used binder is known as dextrine, a type of starch that holds the composition together. The working mechanism of fireworks. Fireworks are stored in a tube called mortar tube or launch tube, which helps the aerial shell to launch into the air in a perfect angle. The aerial shell contains pellets that are arranged in a specific shape. It also contains a burst charge that creates explosions in the sky. The main fuse is ignited, which lights the lift charge and results in the generation of heat and gas. This will push the aerial shell into the sky while the time delay fuse ignites. Over some time, the burst charge explodes, and the pellets burn and expand in the sky based on its arrangement. Diving deeper into the chemistry, when the fuse is fired, the heat produced will initiate the decomposition of the reducing agents. Upon decomposition, nitrates, chlorates, and perchlorates give off oxygen. Nitrates only give up a third of their oxygen. Chlorates get completely reduced and can cause extreme explosions. Perchlorates contain even more oxygen but are less likely to explode than chlorates due to their increased stability. The sulfur and carbon elements in the fuel combine with the oxygen, producing the hot gases, sulfur dioxide and carbon dioxide, which are air pollutants. Sulfur dioxide and carbon dioxide are both air pollutants that are considered greenhouse gases contributing to global warming. Sulfur dioxide is a bent-shaped molecule consisting of sulfur bonded to two oxygen atoms. Its impacts include environmental damage, where it can react with the water molecules and other chemicals present in the atmosphere to produce acid rain. Sulfur dioxide can also irritate the lungs and the throat. On the other hand, carbon dioxide is a linear molecule consisting of a carbon atom that is doubly bonded to two oxygen atoms. It is a primary heat-trapping gas resulting from the different anthropogenic activities. Its impacts also include environmental damage, where an increase of carbon dioxide reduces the Earth's ability to cool itself. Other than environmental damage, it also is a potential health hazard. Its effects include headaches, dizziness, restlessness, and convulsions. Moreover, carbon monoxide may also be produced due to the incomplete burning of materials. It combines with atmospheric oxygen to increase carbon dioxide concentration. This will adversely affect the environment by leading to global warming and ozone depletion. Large amounts of carbon monoxide can cause loss of consciousness and suffocation. Combustion particles are also released into the air and blown by wind currents, causing their dispersal. PM 2.5 are the main cause of reduced visibility or haze in parts of the United States. Also, particular matters can stain and damage stone and other materials, including culturally important objects such as statues and monuments. During the explosion, metal salts do not burn up and may end up as aerosols. As a result, they pollute soils and bodies of water. When inhaled or ingested, aerosols can cause a huge variety of short and long-term reactions, ranging from vomiting, diarrhea, or asthma attacks to kidney disease, cardiotoxic effects, and a variety of cancers. Oxidizers, such as perchlorate compounds, can contaminate bodies of water near the fireworks displays. They also emerge as potent thyroid disruptors. When firework displays disappear, it seems that they have lived into the night, leaving no trace of issues. However, this is far from what truly happens. The truth is, they leave behind billions of particles that may lead to an increase in the concentration of harmful chemicals in the atmosphere. With the emergence of progressive technology and media, the possibility of fireworks display charging less than these adverse health and environmental effects might be just around the corner. One of the most looked upon alternatives to fireworks is the illuminated drone and laser light show. More than the tingling sensation that this new form of sky art shows, it does not possess the impacts that come with burning gunpowder and metal in fireworks. So why switch into drone light shows? Drones are reusable. Unlike fireworks, which are gone once you light them, you can use drones in different patterns over and over again. Despite the aesthetic appeal and excitement fireworks display bring us, the underlying effects of its aftermath impose problems that seem to be risky for a few minutes of magical moments. With this alternative, we can have even more magical light shows, while leaving more of a healthy environment for the future generation to enjoy.